Hey, how's it going everybody? Today I'll demonstrate how you can leverage a state-of-the-art pre-trained deep learning model from FastAI to build a neural net for your own application. In this demonstration, I'll be using a CNN to binarily classify pet images as cat or dog. I do have a few machine learning and data science courses under my belt, but really I'm just only getting started with deep learning, and I found that doing something such as fine-tuning CNN is not as difficult as I had originally believed, thanks to modern tools from Anaconda, FastAI, PyTorch. So before we get started, I'm going to assume that you're starting from scratch on a fresh operating system, so we're going to need to download a few things and install them. The first thing that you're going to need is a Python environment. I'm going to be doing everything through Anaconda, so if you want to follow along with me, then you can download it here and install it. So once you have that installed, we can go ahead and open up Anaconda prompt. And in the prompt, we can make a new environment for our deep learning project. You can do kind of create name deep learning project or whatever. And specifically, we're going to be using Python 3.7. And you could try 3.8 or 3.9 if you'd like, but for this demonstration, we're going to stick to 3.7. And this is what you would do if you didn't have an environment already set up, but I do. So I'm going to go ahead and activate my Python 3.7 FastAI project. And with this new environment, we can go ahead and start installing packages. The first package you'll need is FastAI, and you can get it from anaconda.org/FastAI/FastAI. It's just this command here. You can paste it into your Anaconda prompt and run it, but like I said, I've already got everything set up, so I'm not going to do it again. The next package you'll need is Jupyter. And finally, you'll do IPY widgets. And before we even jump into the code, I'll show you how we can run Python on our GPU rather than our CPU. This is optional, so you can skip ahead if you'd like, if you don't have a local GPU or don't care. I'll demonstrate how to do this because it took me a bit of troubleshooting to figure it out for myself and get it working, and the performance increase is quite noticeable if you go this route. The first thing you'll need to do is check if your GPU supports CUDA cores. And if you don't know what GPU you have, or if you have one, you can go into Windows here and type in system information and go in here, and it'll tell you what GPU you have, or if you have one at all. And once you know what GPU you have, you can go into Google and type in the GPU, and like mine is a RTX 2070 CUDA support. And I mean, it'll tell you if it supports it or not. Mine does. So the next thing you'll need is to download the CUDA toolkit from the NVIDIA website. This is what's going to allow your GPU to interact with CUDA. So you can go to developer.nvidia.com, CUDA downloads, and you can download it for whichever OS you are on. Probably Windows if you're following along with this tutorial. I already have it installed, so I'm not going to download it here. And the last thing you'll need is a custom PyTorch package, because apparently the PyTorch that is installed under FastAI is not CUDA ready, so we'll have to download a fresh package from the PyTorch website. And you can pick your configuration here. This is mine. I picked the latest version of CUDA. And so we can actually take this this command and paste it into your Anaconda prompts and run it, and it'll install it that way. I'm not going to do it because I have already done it. And if you did everything correctly, then your environment should be CUDA ready. We can check by going into Python, importing Torch, and checking if CUDA is available. And with this, we'll move into the code. So we'll quit out of Python here, and we'll open up a Jupyter notebook. And in here, we'll start a fresh notebook, Python 3. And we can name it FastAI example. So in our notebook, we can start by importing libraries. For now, we'll just import all from fastai.vision. No errors. We can define a path to our image dataset, our pet image dataset, that is. We'll print the path for debugging purposes. And we need to define a label function, a way for our model to classify something as either cat or dog. Feed it X, which will be the photo. And we can check what the appropriate label should be by checking the file name. If the file name is capital, if it starts with a capital letter, then that means the label should be cat. And I'll show you what is going on here. If we go to this file path, we can see this is our data set that we're working with. All these cat and dog images. And you notice that all the dog photos start with a lowercase letter, and all the cat images start with a capital letter. And this isn't like cheating. It's not, the model isn't classifying it based on the file name. It's just giving it a label based on the file name. And so now that we got a label function, this next step, it's going to be a 3-step process. First, we'll define our data loader. Then we'll get our pre-trained model. And finally, we'll fine-tune the model with the data loader. So we can start by defining DLS, which is our data loader. We can say image data loaders from name function. And we can feed it path. We can say get image files from path. We'll define the label function as we just did above as my label function. And we can transform each item. We'll resize it to 224 pixels. Because you'll see in the in our data set here, some of these photos they're not all the same size, so we want to normalize them. And something important that we want to do here is we want to specify that we want this to be computed with CUDA for performance reasons. Next, we can get our pre-trained model, which of course is a CNN. So FastAI's naming conventions say to call the model learn, so that's we're gonna follow that. Our CNN learner specifically, we'll feed it our data loader. We'll be using the ResNet 34 state-of-the-art pre-trained model from FastAI, which, as we know, is trained on millions of objects. It's a object detecting model. And for our metric, we'll use error rate. It seems pretty standard for CNNs. And lastly, we'll fine-tune under 2 epochs. And hopefully we don't get any errors. So this will take a minute to compute if you're using a GPU. If you're on a CPU, then I'm sorry, but it's going to take a long time. Maybe a half hour or so. So I'll see you when we're on the other side of this. Okay, so we're done, and we see some pretty promising metrics here, even after just 2 epochs. Because remember, this is a state-of-the-art pre-trained model. It don't get no better than ResNet 34. And if it's not already clear what's going on here, we're using an object detection CNN from FastAI, specifically ResNet 34 here. 34 meaning 34 hidden layers. We're leveraging this pre-trained model for our own application, where we'll be classifying an image as either cat or dog. This is done by fine-tuning the model like we just did with 2 epochs, with our own smaller data set in our data loader. So hopefully all that makes sense, because now we're going to put the model to the test by giving it a photo of my own pet. So we'll start by getting my pet photo and pasting it for simplicity's sake into this data set here, just so the file path is easier to grab. Image 1042. And I think these need to be forward slashes in Python. And finally, image 1042. Oops, I wanted to say image here. And we'll print the image just so we can see what we're looking at. No such file or directory. Oh, you know what? I think it's a JPEG. And there she is, my Maggie. And so what we can do is we can ask the model to predict using learn.predict. Remember, learn is the name of the model, and we'll predict the image. But this function call is going to return a few different things. It's going to tell us is cat and the probability that it's a cat. And so now we can print out the model's predictions, and I've already got some format strings ready, so I'm just going to paste them in here. We're checking, of course, if this is a cat, printing out the probability that it's a cat. But this is a binary classification problem, so if we just take 1 minus the probability that it's a cat, it'll tell us the probability that it's a dog, so we can kind of see it from both sides. And so let's run it and see what happens. I'd say that was a pretty good prediction. And we know that it's not based on the label, because it's a capital I here. So that concludes my demonstration for now. Maybe I'll make another video when I learn how to do more with this. Maybe when I work with other models, I'll make videos on them to kind of refine my knowledge and prove to myself that I understand what I'm learning, and hopefully to maybe share with somebody else and help them understand it as well. So yeah, thank you for watching.